Hello everybody. Today somebody sent me this question from my math lab, and I always like it when that happens because it gives me a chance to see what people are struggling with, and in this case a chance to make a video about it. Okay, so it says to find the derivative of this function and then evaluate it when the variable is 25. Okay, and I've got the answer right here, and I want to show you how I came to that conclusion. First of all, I won't hide the fact or deny the fact that there's technology out there to help us with this kind of thing. So I'm going to say that first, just because I think it's important to address that. I'm sure there's so many ways you could do this, but I've been using Wolfram Alpha for a long time, and you can type in whatever mathematical operation you want, and it will probably take care of it for you. So I took this function 8 times square root of t minus 9 over root t. There it is right there, and I said derivative of that, and it gave it to me. Whoops, hold on. Right there. Okay, so it's telling me that that's the derivative. 8t plus 9 over 2t to the 3 over 2 power. So I could do that. All right. And then I could even say if, what did that question say? T is equal to 25. So to evaluate the derivative when the variable, t in this case, is 25. So I could type that in, and it would tell me, oh, well, okay, it's 209 over 250. Okay, and that's the answer that I put in. Now, I'm not against technology, and I think everybody in the class should know about it. But as it stands right now, our curriculum is for you to learn to do this by the rules of calculus, okay? And there are reasons for that. Maybe someday the curriculum will change, but as it is right now, that's the way that it is, okay? So let's work through how you'd find the derivative on your own without some calculator or software to do it for you, okay? So let's see. First of all, we'll talk about some algebra that's involved in getting that function to the point where we can apply the rules of calculus. Now note what I have here is not the same thing as this. This is 8 root t minus 9 over square root of t. But roots are convertible to fractional exponents. So if the a root of x to the b power is x to the b over a power, then the square root of t to the first power is t to the 1/2 power, okay? And with negative exponents, if I have 1 over the variable x, and I'm just using x, I could use xt, a, b, c, whatever. 1 over x to the power n, that's convertible to a negative exponent, x to the minus n power, okay? So that's why with this second term, 9 over root t, I have, well, that's like 1 over t or x or whatever you want the variable to be to the 1/2 power, and then if I move that like so, then it would be to the negative 1/2 power. So that's how I rewrote this. Now, as far as the rule that's applicable to find the derivative goes, it's this one. If I have a function that says that the variable is to some power n. So let's say x is the variable and n is the power. In this case, t is the variable, but the variable could be whatever letter of the alphabet you want, all right? Okay, so then the derivative of that, you bring the power down and you subtract 1. It's a fairly easy rule. You may have to do some calculations with the fractions and so on, but as far as math goes, this rule is not that hard. So here's how I can find the derivative. With that coefficient of 8, the rules of calculus are also such that we carry that down. As far as the derivative of t to the 1/2 power goes, according to the rule, we bring the half down, the exponent, and we subtract 1. 1/2 take away 1 is negative 1/2, okay? As far as the rules of calculus go, we would carry down any addition or subtraction, so that subtraction gets carried down here. And again, the coefficient of 9 carried down. And then the derivative of t to the minus 1/2 power, you get minus 1/2. Okay, bring that down. And then I have to subtract 1, right? So what's negative 1/2 minus 1? That's negative 3 over 2. Okay, now I'll work on this a little bit. Like, so for example, 8 times 1/2 is 4. Okay, so I'll get 4 times t to the negative 1/2 power. And 9 times a half, well, I'll write that as 9 over 2. And a negative times a negative is a positive. So I get like so. I'll do one last thing. I'll convert my exponents back to be positive numbers and roots. So according to the fact that anytime we move something from either below the fraction bar or above the fraction bar to the other side, then the exponent changes sign. So this becomes 4 over t to the 1/2 power, which is the same thing as 4 over square root of t, okay, according to this rule. And then that becomes 9 over 2 times t to the 3 over 2 power, which I wrote like this, according to this rule, okay? Now I wrote it like that because I wanted to show you how, you know, all the facets that might be involved in doing this, you know, whenever you might encounter it, okay? Maybe you could leave the answer like this, but, you know, I don't know what you'll encounter someday, and I just want you to be prepared, okay? So I want to make sure you see how I got from here to here. There's our derivative. Okay, now that question was to evaluate the derivative when the variable was 25. So I'll take this, the derivative, I'll let t be 25. And that looks like this: 4 over root 25 plus 9 over 2 root 25 third power. With a calculator, I did this part, okay? And the square root of 25 to the third power turned out to be 125. So now I'm here. I get 4/5 plus 9 over 250. At this point, I'm thinking, okay, I need to add these fractions together. I did notice in the question it said simplify your answer, type an integer, and an integer is a positive or negative whole number, and a fraction is a fraction. You know what a fraction is. So I need to add these together into one fraction. All right. Now I know that we kind of cheated a little bit and we used Wolfram Alpha and it told us the answer is 209 over 250. But I said that, like, you know, I want you to learn to do some math on your own. Technology's okay, but I want you to learn how to do the math on your own also. All right. Okay. And that's the way our curriculum is. You have to submit work on the test for some of the questions, and I'm going to want to see your steps consistent with how I've been teaching in the videos and so on. So, okay, I got to add these together, and in order to add fractions, I need a common denominator, okay? That common denominator between these fractions will be 250. So the way we do that is I took 4/5, I multiplied by 50 over 50. Why do you do it that way? You know, if you say 5 times 50, that's 250. That'll get you the common denominator. Why do we multiply on top also? Well, because what's 50 over 50? 50 over 50 is 1. So I got the number 4/5. I can't change that to some other number that's different. So whenever we get a common denominator like this, we're just multiplying by 1. And that way we're not changing anything. We're just changing the way that it looks. It now has a common denominator with the other fraction, and that's what we needed. So I get from there 200 over 250 plus 9 over 250, and then I can just add across the top 209 over 250, and then we're done. Now, that's the kind of thing I'd like you to know how to do. You might not want to, you know, it's far easier to use something like Wolfram Alpha to tell you the answer. Of course, all right? Of course that's easier. But part of you being in the class, as I said already, is that you learn to do the math yourself. I have more confidence in you for whatever you do beyond our class. That's technical, mathematical, quantitative. I have way more confidence in whatever you encounter if you learn to do the math yourself. So challenge yourself, learn how to do things. You rely on calculators sometimes, that's fine, but this is what I want to challenge you with for the time being.